transfer, we can reduce injuries much more effectively than we're doing now. If we go down the path of guilt, blame, and fault, we will never achieve that goal. It is distracting us from our mission. It will prevent us from being effective. Next slide. And here's an example of a scooter and a child. Notice the child is wearing a helmet in this picture. Next slide. Next slide. We know from studies that helmets will prevent up to 85% of major brain injury if worn in a crash. And how does it do that? It focuses on the cause, which is the energy transfer. It spreads that energy on impact over space and time so that the brain does not have the amount of, the energy transfer does not exceed its limits, its energy thresholds. So that's how we conquered, in this example, a major injury by focusing on energy transfer. Next slide. Now we've known this for years. This is a gladiator helmet, thousands of years old. We know this principle. We've used it for many years. Next slide. So number 2, how can we better prevent injuries to children? And that's design the problem out of existence. That's what we did in the example of the waterborne illness. We built the latrines, the sewer treatment plants, the potable water systems, and we've had dramatic results. Next slide. Here's an example of one that I saw way too many times when I was in training a number of years ago. And these are baby walker related injuries. You have baby walkers here in Thailand, I'm sure. They can move at 1 meter per second. The fastest parent that you can show me can't move quickly enough to stop a child from going down the stairs once they start toward that door. Next slide. We did a study at my hospital, Nationwide Children's Hospital, that had more than 270 children in it. It's still the largest study ever done on a series of children with baby walker injuries. And what I want to show you is that almost 1 out of 10 children, almost 10%, had a skull fracture. We were seeing more than 2 children a week, and that's just in one hospital. So not only were they frequent, but 10% had skull fractures. This is a serious injury, serious mechanism. 3 of the children had bleeds in their brain. 3 had depressed skull fractures. Next slide. And I showed this for the clinicians in the room, because you folks like clinical stuff. This is a CT scan of the head. And up to your upper right, you can see that little, thank you. For the clinicians, they know that that's called an epidural hemorrhage. It's a bleed from an artery inside the head. And depending on its size, that can be life-threatening. And this was a child who fell down 10 to 12 stairs and landed on concrete in a baby walker, 9-month-old. Next slide. This is a 10-month-old who also fell down stairs in a walker, only 8 stairs, struck concrete on the floor at the bottom. And this is a different injury. You can see on your left, underneath the skull, there's the subdural hemorrhage with lots of brain swelling and a shift to your right from the pressure. This child had a Glasgow coma score of 3. That's the lowest you can get. The child was intubated, was in the intensive care unit for a number of days, and finally was sent home. What if I told you that when we called the parents a month later, they told us that the baby was back in the baby walker? What's your reaction? I would say most people would say, stupid parents, ignorant, poor judgment. They would blame the parent. Again, this is the problem. It's the guilt, blame, and fault approach. It turns out that what's going on here is the fact that the parent also blames themselves. They are convinced that it was their fault, not the baby walker's fault, their fault that the child fell down the stairs. And next time, they were going to watch the child more closely. They were going to be a better parent. And they bought the myth that this device could be used safely. And why? Because most of their neighbors had them. They had one when they were a child. They thought it wasn't the walker, it was their problem. And that's why guilt, blame, and fault distracts us from the real issue, which is that this is simply an inherently dangerous device that should not be used by children. Next slide. So we did a number of things, including going to the newspapers and having TV cameras show up. We collected walkers and crushed them with the TV cameras rolling. This is a much younger Dr. Smith. Next slide. But then something happened. Like a walker, but they don't have wheels. And so it doesn't allow the child to roll across the floor at 1 meter per second. They're falling downstairs in the home. Next slide. Another thing that happened following that was there was a revision in a safety standard that applies to baby walkers. It went into effect in June of 1997, and it meant that walkers had to be either too big to fit through one of the examples, one of the first, I think it was the first example of one that was too wide to fit through a doorway. It would prevent falls downstairs, which in our study accounted for 95% of the injuries. And what's more popular now is this device, and you can see down at the floor, there's that red strip that goes around the bottom. There you go, thank you. That's a friction strip. So if the yellow little wheel goes over the top stair, that red friction strip will grab the floor and keep it from falling all the way down the stairs. Next slide. This is what happened in our country. These are data from emergency departments throughout the country. This was a study that we published looking at data from 1990 through 2001. The first arrow indicates when the exerciser in 1994 was made available to consumers and gave them an alternative to walkers. And in 1997 is when the new revised safety standard came into place. And you can see there was a dramatic decrease in the number of emergency department visits for baby walker related injuries to young children. Now let me tell you something. This is rare. This is the type of response we see with a new vaccine. When the influenza B vaccine came out, the Hib vaccine, we saw decreases like this. See this in injury field. So what did we do right, and what can we learn from this? And what I'm going to tell you is, we focused on the cause, which was the fall down the stairs, and we didn't look at guilt, blame, and fault of the supervising parent. We designed the problem out of existence, which was the number 2 item I had for how we're going to decrease injury. So we need to learn from this and apply this approach to other types of injury to children. Next slide. Next slide. So, I've been working in the field now for over 30 years. I've been an emergency department physician for at least 20 of those. You start to think, well, I've seen that, but you always see something new when you're working in the emergency department. So one day, I was working in an emergency department at Johns Hopkins University, and a nurse hands me a chart This is back when we had charts, of a child who was hit in the head with a hamburger. And I thought to myself, this is odd. How could that be a reason for coming to the emergency department? Maybe something got in the child's eye. Who knows? So I went into the room, and I must have looked rather strange and surprised, standing there looking at a child with this big, big bruise on his forehead, big lump. And I said to myself, how long was that hamburger underneath that warmer light, you see, to get so hard that it would cause this kind of injury? I was very confused. And so being a good doctor, I said to the mom, ma'am, was this a cheeseburger or a bacon cheeseburger? She said, no, doctor. You don't understand. Next slide. Next slide. It was the hamburger head form on his toy outside the restaurant. So I felt foolish. But I show you this slide because it's important that it illustrates a key point in injury prevention. If this hamburger head form had been designed using a material that absorbed energy, as that child rocked back and forth and struck his forehead against that, the energy transfer would have been below the tissue level, tolerance levels, and an injury would not have occurred. So here is one of the most important things I'm going to say today. You can prevent the injury without preventing the event. You can prevent the injury without preventing the event. If you focus on the cause, which is energy transfer, if the event occurs, the child strikes his head on that head form, but the energy transfer is not high, you've prevented the injury, even though the child struck his head. It's a very important concept, and it's because we're focusing on the cause. Next slide. Next slide. This is hard to see with the lights, but this is a standard crash test using crash dummies. The top one shows an airbag that's been deployed. This is about 35-mile-an-hour crash, frontal crash. The same crash is below, but without an airbag, and it's hard to see there, but the steering wheel has been bent forward by the forehead of the crash test dummy striking it. So lots and lots of energy transfer in that lower picture. If this was a real person, that airbag would have distributed the energy over space and time, and the amount of energy transferred to the body would not have exceeded the tolerance levels, and that person would likely have walked away from the crash. On the bottom, that is likely to be a life-threatening injury. We can prevent the injury without preventing the event. The crash can still occur, but if we focus on the cause, which is energy transfer, with this kind of technology, so concrete will cause tremendous amounts of energy transfer. So instead of using a hard surface like such as this, so again, you can design the problem out of existence. Next was under the playground. And that's why we saw so many serious injuries. So this is a great example of what not to do. Well, number 3 is to use what we call passive prevention approaches rather than active. Next slide. And what is the difference between them? So active prevention approaches means that you have to take action for the protection to occur. So if you're wearing a seat belt, you have to actually buckle up the seat belt. You have to take action before that will provide the protection for you. If you rely on supervision of the children, that's an active approach and it's less effective. It requires a parent to be there or a teacher to be there watching the children all the time, and we know that that does not work consistently. Next slide. So these are a couple of examples. On your left, we have, on the vertical axis, we have the likelihood that infection will occur. Toward the top of this type of graph, the figure is maximal protection. Toward the bottom is minimal. It's right there. That doesn't really require any effort, very little effort on the part of the parent. It's been designed in a way to keep the child from rolling across the floor at 1 meter per second. So it's going to have a much higher likelihood of protection. Going back to the bottom, constant child supervision to pass this law has shown a decrease in the number of injuries, the number of deaths due to house fires caused. And that little object right there is a hot dog. I tell people that if you were to go out and design the perfect plug for a child's airway, you couldn't do better than a hot dog. It's the right diameter, it's round, and it's compressible, and it will wedge itself in. They're almost impossible to get out once they wedge themselves in, even with correct equipment. And they cause suffocation from choking. Next slide. This is a gel candy. This gel candy was marketed in a number of countries. There were deaths to young children in Japan, in Canada, and in the United States. If you look at the yellow example there on your right, it's round like a hot dog. It's designed to be sucked out of the container. You put it up to your mouth and you suck, it slides back into your mouth. It's very slippery, but it holds its shape. And it will go to the back of the throat and plug the airway just like a hot dog. We should have known that this was going to cause choking deaths to children because it had all the same dimensions and characteristics as a hot dog, which we knew was the leading cause of food choking death among foods in the U.S. So this was eventually, after I could tell a long story on this, but it was eventually taken off the market. But it's an example that if we would have used what we knew about the characteristics of this product and compare it to what we knew were choking threats, we could have prevented the injury, or prevented these deaths. Next slide. And another example is something called saw stop. This is an ingenious example of engineering helping injury prevention. The person who invented this was an engineer who also has a hobby, did woodworking. And what it does is it puts an electrical charge on the blade of the saw. These are table saws or skill saws that rotate at thousands of rotations per minute. Puts an electrical charge on that saw blade, and if you put your skin, if your skin comes in touch with that, it will dump the charge, it will make the charge leave the blade, go into your tissue, that's immediately sensed by a sensing device that samples the electrical charge several times for every tooth of the saw blade as it's rotating at thousands of times per second. It will immediately sense that and cause the blade to drop away and to stop. I talked to an engineer at the Consumer Product Safety Commission that saw this demonstrated. And the inventor told the story of the first time that he put his own finger into the blade. Can you imagine? He had a little scratch on his finger rather than having it completely amputate his finger. And so this is an example of automatically designing the problem out of existence and not relying on human approaches. So we're combining the education of good practices when you're using these kind of this kind of equipment with design changes that will help prevent the injury. Combining approaches. Next slide. And this will not work because it's not hooked up to the internet, so we'll just move on to the next slide. So the final the final suggestion I have for preventing injuries is following the axioms of injury prevention. Next slide. Some of them I've talked to you about, the choice of passive approaches rather than active, but also looking for the weakest link in the chain of events, where you can intervene and have most likely be able to stop that chain of events to prevent the injury. If you do use active strategies that require people to take action, use those that have been evaluated. There's story after story of programs that have been designed and used widely, but when they're finally evaluated, they're shown to be not effective. So choose those approaches that are, when you choose an active strategy, choose those approaches that have been studied and shown to be effective. Target the people at the highest risk, especially when you have limited resources, and then combine incentives and reduce disincentives. So when you design a car seat, make sure that it's easy to use, so parents have the disincentive of, I can't do this, it's too hard to use. And then always combine countermeasures, meaning if you do an educational approach, also look at design changes, look at environmental changes, come at the problem from multiple different approaches. That's the best way to be effective in reducing the injury. Next, also for other animals. So I'm going to show you this, but promise not to tell anybody. It's really an exciting idea, and that's this one. Next slide. So thank you for your attention. Thank you very much.
มีใครมีคำถามหรือความคิดเห็นอะไรบ้างไหมครับสำหรับเสียชัยเชิญครับเชิญ
The motivation factor for the people concerned is the children. Inspiration for them to find some measure to prevent the children is very important. With the routine work, they don't have opportunity to think about innovative measures. So, what is your suggestion that what we should do to have some people to have an innovative idea to prevent children like this?
The question is saying that parents and those that care for children have their own work to do. They don't have the time to think of innovative approaches to prevention. What can we do to help them? Okay, so I like to say that unfortunately we live in a world where the environments and the products have been designed by adults for the convenience of adults, and child safety is often simply an afterthought. We have to do a much better job at designing our environments, including our homes, our products, and not only products for children, but even for adults that kids get access to. We need to do them in a way that will prevent injuries to children. This afternoon we're going to have a session on consumer product safety, and there are example after example after example of products that are used by adults for their convenience, but unfortunately because of the design pose significant threat of injury or even death to children. So we have to be much better at designing our environments so that parents don't have to try to supervise their child every moment, because we know that it's impossible. I have 2 children. I spend most of my waking life thinking about injury, but I can tell you I have never been able to watch 2 children 100% of the time because I have other things I must do. So we have to provide those environments and those products so that parents don't have to do that. Injury individuals, no matter where you live in the world, carry a much greater burden of injury than individuals that have high income. We need to do better at making sure that we share the resources needed to keep our children safe, no matter whether they're from low income or high income families. Because unfortunately many of those technologies are simply out of the price range for many families. So we have a lot of work still yet to do. But it took us 150 years to conquer many of the infectious diseases, and we're still working on many of them. So we won't change this overnight. But if we use the approaches that have worked for infectious disease and other public health problems, if we approach the idea that we can eliminate these injuries and have that vision zero that Sweden has done so well with, we can make a huge difference. But it's going to take us all working together. It's going to take us understanding what is an effective approach and not simply blaming the parent or even blaming the manufacturer or the politician because they haven't acted. Let's all work together. Let's find the common ground. Let's come up with strategies that are affordable and accessible and implement those in the environments where children...
It can be. It was banned in US, Canada, so many countries. It was banned, right? Not yet?
Yeah, it was banned. It was taken off the shelves.
Yeah, but if you want it, you can buy it somewhere here.
It doesn't surprise me.